All right, today we're going to build a little network detective. It's a Python script designed to monitor ARP traffic, which basically means it watches who's who on your local network. But more importantly, we're going to tackle that one single headache that always seems to pop up with projects like this.
You know the feeling, right? You write this awesome networking script, it works perfectly on your machine, but then you try to run it on a friend's Mac or Windows laptop and poof, nothing. It's a super common problem, and today we're going to get to the bottom of it. So let's just dive right in.
So what is this thing we're building? It's an ARP monitor. Honestly, the best way to think about it is like a little neighborhood watch for your network. It just sits there, quietly listening to this one specific type of traffic, ARP traffic, and it keeps a log of which device is using which IP address. It's super useful for troubleshooting, but it's even better for security.
Okay, before we can actually monitor ARP, we've got to have a quick chat about what it even is. It's one of those really fundamental bedrock protocols on your local network, and you'll see it's actually incredibly simple.
When you boil it all down, ARP is just a simple question and answer. One device on the network basically shouts out to everyone, "Hey, who out there has this IP address?" That's a broadcast. Then the one device that actually has that IP address sends a reply, but only back to the original asker saying, "Yo, that's me, and here's my physical hardware address." And that's it. That's the entire conversation our little monitor is built to overhear. So what are we actually listening for? Well, it's really three main events. First, we're looking for any new MAC addresses we've never seen before. That means a new device just hopped on the network. Second, we're watching to see if a device we already know about suddenly changes its IP address. And third, and this is the really important one, we're watching to see if an IP address we know suddenly gets claimed by a brand new device. And that third one, that is your big security alert. When a familiar IP address, say your router's IP, suddenly starts being announced by a completely different MAC address, that is a massive red flag. It is the classic textbook sign of an attack called ARP spoofing, and that's exactly what a good monitor VO is designed to catch.
Okay, so we know what we're looking for, but how in the world does a simple Python script actually hear all this network chatter? Well, the technique we use is called packet sniffing. The whole process is really just a simple four-step loop. First, our script starts sniffing traffic, but it's not trying to drink from a fire hose. It puts on a filter so it only sees ARP packets. Then, from each of those packets, it pulls out the two most important bits of info, the sender's IP and their MAC address. Next, it compares that pair to a little list it keeps in memory of all the devices it's already seen. And finally, if it spots anything new or anything that's changed, boom, it raises an alert. Simple, but really effective.
And now, for the really fun part, what I like to call the gauntlet. We're going to see what it takes to get our script running across 3 different operating systems. And we're starting with our first big challenge, Mac OS.
When you're on a Mac, there are 3 things you just have to know. First, under the hood, macOS uses something called Berkeley packet filter devices to let programs listen to network traffic. Because this is a low-level operation, it requires special permissions, which means you have to run your script with sudo. And last but not least, the network interface names are different. Your Wi-Fi is probably named EN0, not the classic ETH0 you might be used to from the Linux world.
And really, this is the whole story right here. The 2 biggest reasons these scripts fail on a Mac are super simple. 1, you forgot to run it with sudo, so the script has no permission to listen. And 2, your code is looking for an interface named ETH0, which just plain doesn't exist on a Mac. Get those 2 things right, and you're golden.
Okay, let's move on to our next stop in the gauntlet. Next up is Kali Linux, which, for this kind of work, is pretty much home turf. Things tend to be a bit easier here.
So yeah, on Kali, life is generally a bit simpler. It uses all the standard, well-known libraries for this stuff. Permissions are easy, you just run as root. The one major thing you have to watch out for, especially because so many of us run Kali inside a virtual machine, is the VM's network setting.
Seriously, this is the one detail that gets everyone. If your virtual machine's network is set to NAT mode, the VM basically creates its own little private network bubble. Your script inside that bubble can't see the real traffic on your actual home network. You must switch the setting to bridged mode. That makes your VM act like another physical computer plugged right into your router, and then it can see everything.
All right, it's time for our final and maybe most interesting challenge, Windows. This one has an extra hoop you have to jump through that the others just don't.
So here's the big deal with Windows. Unlike macOS and Linux, it doesn't have a built-in, easy way for a regular program to just grab raw network packets.
To bridge that gap, you need a special driver. The modern standard is a tool called NCAP. Think of it as a translator that gives Python low-level access to your network hardware. Without it, your script can't hear anything. And just like on macOS, you've got to pay attention to the interface names. They're friendly names like Wi-Fi, not ETH0.
Let me be absolutely crystal clear on this one. You could have the most beautifully written Python script in the world, but if you run it on a standard Windows machine, it will appear to run and it will see exactly 0 packets. Nothing. You have to install the NCAP driver first. It is, without a doubt, the #1 reason this kind of script fails on Windows.
Okay, we made it through the gauntlet. We got the script running everywhere. But now it's time for a little reality check. What can this monitor actually see out there on the network?
So our monitor is fantastic at spotting the big noisy events on its own little slice of the network. Things like IP conflicts, new laptops joining, or that critical gateway MAC address changing. But it's not a magic crystal ball. It can't see traffic happening on totally different network segments, like say different VLANs in an office. And on a lot of modern Wi-Fi networks, for security reasons, it can't even see the traffic going directly between 2 other wireless clients. It sees what it's directly exposed to, and that's an important limitation to understand.
All right, let's bring this all home. We've gone through the unique quirks and challenges of each operating system. Now, let's put it all side by side in one place, the ultimate cross-platform cheat sheet.
Think of this as your troubleshooting Bible. On a Mac, I guarantee it's almost always a permissions thing. You forgot sudo or you're using the wrong interface name. In a Kali VM, it's that sneaky NAT mode every time. And on Windows, 9 times out of 10, maybe even more, it's because the NCAP driver is missing. If your script isn't working, just come back to this slide. The answer is probably right here.
See, once you understand these little platform-specific details, you can stop writing scripts that only work on my machine and start building tools that are genuinely robust and can work anywhere. The conversation on your network is happening 24/7. The only question left is, are you ready to listen?